Hello everybody, this is Cilium Zero Trust Policy Visualizer, a small Cilium inspired project that shows how we can enforce zero trust network policies using eBPF, XDP, and then visualize which flows are being allowed or denied in real time. So in many environments, we say we enforce zero trust, but it's hard to answer basic questions. One, which flows are being allowed right now? Which flows are being silently dropped by the policy? And can I see that behavior live, not just from the logs? So basically, this project solves that by combining an XDP eBPF program that enforces a default deny policy, a user space loader that exposes the eBPF maps as a REST API, and a small web UI that visualizes flows versus policy decisions in real time. So let me quickly walk you through this repository structure. At the top level, we have this eBPF. This contains kernel C, kernel space eBPF code. So basically, this is our XDP program that actually enforces the zero trust policy. And we have common.h. This shares the structs and BPF maps for policy and stats. And here we have a user space where we have the loader.py file. This uses the BCC to compile and attach the eBPF program and loads the YAML file and expose a Flask REST API. So under the config, we have a policy.yaml, a simple YAML file that basically defines which flows are allowed and denied. In our case, I'm running it on the VM. This is my IP 192.168.86.250. So that's where the source IP and the destination IP, when I curl from 1.1.1, the action should be allow, it should allow, and rest if I the curl from 8888, then it should deny. So if I go to the web UI, we have a app.js, index.html, and style.css. So they periodically call the REST API and render tables and policies and observe flows. If I go to the scripts, under scripts, we see that demo.sh. It's a one-liner script to run the demo end to end on a given interface. So in our case, it is ETH. Um, in our case, it should be ENS 160. Um, and we have a Docker file. It's actually a container image with everything included, and we have a daemon set.yaml, a daemon set that runs this on every node in a Kubernetes cluster. And let's go to the architecture diagram. So here, this is a high-level architecture of the system. Starting at the bottom, here is the incoming traffic, hits the XDP hook on NIC. Our eBP program, this XDP underscore ZT underscore policy, parses the Ethernet, IPv4, and TCP and UDP headers. So it builds a flow key consist of source IP, destination IP, ports, and protocol. Then it looks for the flow in the policy map. So if there is a match and the value is 1, we treat it as allowed. If there is a match with 0 or no entry at all, we treat it as denied. So on top of that, this is basically the we have the user space. Loader.py is like uses the BCC to load and attach the XDP program to a specific interface, and it reads the policy.yaml file and populates the policy map in the kernel, and then it exposes a Flask REST API. So we have this two API endpoints. One is a get API policy, returns what's in the policy map, and the API flows returns what's like stats underscore map. So finally, we have a web UI, that talks only to this REST API, polling both the endpoints every few seconds and rendering two tables, one for the configuring zero trust policy and one for the observed traffic, and it is allowed or denied counters. So, and let's go to the live demo. So I'm running it on the Ubuntu VM machine um, with eBPF and XDP support. So this is my Ubuntu. So basically I have logged in from here. Um, okay, so I have already installed the prerequisite, for example, like Python BCC, libbpf, and flask. So to run this demo, I just use this helper script and pass it to the interface, for example, ENS160. It might be ETH0 in your case if you're running it locally, not on the VM. So now I'm gonna add password here. So now, like I'm gonna generate some traffic so that we can see that the zero trust behavior. Here before that we're gonna see here it's trying to authenticate, and then it's using the interface ENS160. It started the loader, and here you can see that it loaded the eBPF program, and then using this directory attach the XTP program to ENS160, and this is where we have a hard coded the policy which is available in here, and then XDP zero trust classifier got loaded. So here we can see that what are the allowed traffic and what are the denied traffics. So let me pass this 111. Okay, and basically I'm gonna run the for loop for google.com, and then we can see that the counters increases. Yeah, you can see that here it's allowed and denied counters. So finally, to summarize this, like how to enforce a default deny zero trust stance using eBPF and XDP, and how to visualize allowed and denied flows in real time. So basically it's a impact end-to-end project that captures the core idea behind the Cilium and Hubble in a way that's easy to understand. Yeah, thank you so much for watching.